Yep. Sign out for me, please. What? No. Yeah. Okay, so 4.6. What? People, why don't you go on going over the homework instead of when I'm going to teach you something new? Bad timing. Bad timing. Okay, so we're talking about patterns today. So this word, like if you were to say that word, if we were just looking, we would say the word arithmetic. But when we're talking about sequences, which we'll talk about in a second, then we say arithmetic. It's weird. An arithmetic sequence. So it's weird that it's pronounced different. This is all about patterns is what this is. Okay, so don't steal anybody's learning moment. So my question is, do you see the pattern and can you give me the next number? Okay, what's the next number? 17. How do we know?
It goes up by 3.
Yeah, it goes up by 3. Oh, and did you make it too hard?
Yeah, I thought it was going up by 4.
No, it's going up by 3. It's going up by 3. How about this one? Might need your calculator for this one. That's what I thought. Do you know?
162.
I wasn't asking you. Renee? Is that what you were going to say? Charlie?
What?
What is it?
162.
162. How did you figure that out?
Times 3.
Yeah, you can see that it's multiplying by 3. The early stages of that pattern, you could see 2 times 3 is 6, and 6 times 3 is 18. And then go, I wonder if 18 times 3 is 54. It is, and so then multiply times 3 again, you get 162. Okay, do not steal anybody's learning moment. Shoot. Don't. This is way too easy. I didn't want to do that one. That's okay.
I have a learning moment here. I know.
Don't steal anybody's learning moment.
Hey, give it to Owen.
Owen, what is it?
60.
How do you know?
Because it goes 100, 90, 80, 70, 60.
Follows the pattern. What are we doing? What is it? What is it doing?
Going down by 10.
Yeah, subtracting 10, right? Subtracting 10. Okay.
Aren't you my line 10? I am.
Okay, this time a little bit different. I'd like you to give me the next 3. Okay, I'd like you to give me the next 3. Okay, what's the first one?
56.
Next one? 44. Next one?
52.
Correct. What's the pattern here?
Plus 8.
We're plussing 8. Okay, so another one like that, I want you to find the next three. Let's make sure I'm getting the right numbers. Yep. Just chill out.
Wow. Oh, I got it. Oh.
Okay, next three, please. Okay, what's the next one? 64. The next one? 32. And the next one? What are we doing with this? Okay, now, you guys, sequences, there are a bazillion sequences in the world. I'm going to show you two other ones that are going to be a little bit trickier. Okay, so don't steal anybody's learning moment, please. Oh my word, yes.
Thank you. Why are you sending the tree?
Charlie, why are you yapping? Okay, so that's the one you're looking at. It takes a little bit more thinking here. See what you can come up with, but please don't steal anybody's learning moment. I think I said two. We're going to do three total of these. Everybody know the next number?
25.
It is 25. Okay, what's the next one?
60.
Yep, and the next one?
8.
Okay, anybody figure out, other than Charlie, Charlie don't answer, anybody figure out the pattern? Okay, how much does this go down by?
15.
How much does this go down by?
14.
14. How much does this go down by?
13.
Yep, goes down by 12, goes down by 11, so 10, minus 9, minus 8. Okay, that was sneakier.
Charles, can you just be quiet for once?
Okay, see what you can come up with. Next three, I'm looking for the next three.
Your name is Charles? A little behind on.
Little behind Owen.
Just a little.
There's two ways you can get this one. Anybody other than Charlie know the first one? The next one? Hunter, what do you think?
36.
36. 36 is the next one. What's the next one? Liam?
49.
Yep. And the next one? Charlie?
64.
64. Okay, so my question is, how much does this go up by? How much does this go up by? So 3 goes up by 5, goes up by 7 goes up by 9. So you can see the pattern there. It goes up, going to go up by a lot. Well, yeah. So it's going to go up by 11 then, the next one, because I'm adding 2 to what I'm adding. So the next one's went up by 13. The next one went up by 15. Or you can catch the fact that that is 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. And then go 6, 7, and 8 squared. Okay. Only the next one here. This is actually a very famous sequence. It actually is a name. Named after the guy who came up with it. This one's harder. Any ideas about the next number?
18.
Nope. I told you this one's harder, but once you know the pattern, you're gonna be like, oh, that's so easy. Take these two numbers. What do they add up to? What do these two numbers add up to?
3.
What do these two numbers add up to?
5.
Oh, you
I
got
got
it.
What's the next one?
21.
21. So this is, sorry, this is called Fibonacci sequence, named by Fibonacci, because he's an Italian guy that is the one that came up with this. And this actually shows up in nature. I don't know how, because I don't know how, and I'm too tired to care right now. But that's the honest truth. It's there. We could Google it. It has to do with here. Let's Google it because we can. Just a second. I know. Thank you.
Yeah, you dropped something, Liam.
Oh, yeah. Charles. Thanks for getting the down.
I know, bro. I'm so excited.
Oops, spelled it wrong. Okay. So here you go. Fibonacci sequence appears frequently in nature as a pattern for efficient growth, packing, and structure. It is commonly seen in the spiral arrangements of sunflower seeds, pine cone bracts, which are those things, pineapple fruitlets, blah, 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 blah. Here. So apparently, it's about ratios and things like that. Obviously, I haven't studied this because I'm making stuff up as I go. But look at it's. There you go. Let's go. There you go. So it has to do with things like you can see it. Things that like, especially in your ear, there. Things that start out small and they get bigger, 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 bigger. So there's the shape of the shell. There's the shape of that plant where it gets bigger and bigger. This one gets bigger and bigger. I don't know where the egg comes into it, but whatever. Okay. So anyway, that's Fibonacci sequence. That's all we need to really know about it. So that's what we're talking about, our sequences. So we're going to do a couple definitions here. A sequence is a list of numbers in order. Okay, so the deal with a sequence is it has to be in a specific order because if it wasn't in order, you couldn't find the pattern. So we want to make sure that we have our numbers in the right order, right? Because if there's no order, there's no pattern. Okay? And then a term is each number in the sequence. So that's weird because we talk about when we write down a word and we say, okay, I've got a couple terms for you. That's just basically a word that you need to define. This term means something different in this situation. A term is each number in the sequence. So for example, when I was up here telling you, hey, you can find the next number in this sequence, I could say, find the next term, find the next 3 terms. That's what it will say in your book. Okay, so don't freak out on that. So specifically though, an arithmetic sequence is a specific kind of sequence formed by adding or subtracting the same number every time. So the ones, we did some arithmetic sequence when I was giving you those patterns up there. A lot of them were not arithmetic sequence. Fibonacci, he's not arithmetic because we're not adding the same number every time. The one that's at the top of the screen, not arithmetic because we're adding a different number every time. An arithmetic sequence adds or subtracts the same number every time. Okay, so first question. Is this an arithmetic sequence? Yeah. Okay. If you can say, hey, I know I'm adding or subtracting the same number, then it's arithmetic. I'd like you to find the next 3 terms. Okay. What's the next one? Yep. What's the next one? 42 and 49. What's our pattern here? Yeah, we're adding 7. Okay, how about this one? Okay, I'd like you to find the next 3 terms. Okay, what's the next one? 65. Yep. Next one? Yep. Last one? 47. So, you guys, if you're not sure, you know it's going down, right? Just do 101 minus 92. It'll tell you how much it subtracts. Subtracts 9 every time. Minus 9. Now, there's a last definition I need to give you. It's something called the common difference. Okay? The common difference is the number we add or subtract by. Okay, common difference is the number we add or subtract by. So up here, what was the common difference? 7. What's the common difference in the second one? -9. Yep. Okay, so common difference is the number we add or subtract by. So what we need to be able to do is, I should be able to give you some information and you can build the sequence. So if you build the sequence, let's say the first term is 2 and the common difference is 5. I'd like you to write me the first 5 terms. This, when we have homework on this, which may or may not be today, I don't know. But when we have homework on this is what just part of your homework. It's super easy. Okay, what's the first term? You guys, this is about the easiest question in the entire world. Thank you, because it says that's the first term. What's the next one? 7. What's the next one? 12. Next one? 17 and 22. If this is the common difference, this tells you that we take our first one and we add 5. So 2 plus 5 is 7. 7 plus 5 is 12. Plus 5 is 17. Plus 5 is 22. So take your first term and then add 5. Okay, so let's try again. So let's say the first term is 10 and the common difference is -2. Okay, first 5 again. First 5 terms. Okay, what's the first term? 10. What's the next one? 8. Next? 6, 4, 2. And we're done. There's the first 5 terms. You guys only have to find 4 because it gives you the first one. And then common difference tells you what's happening. You're subtracting 2 every time. Okay, now the last thing we need to be able to do with these guys is we like to be able to write an equation. Okay, so an equation for arithmetic sequences. This is going to look a little bit weird. So it's going to be A with a little n equals A with a little 1 plus n minus 1 times d. Now write that down and we'll talk about what we got going on here. So usually our equations have x's and y's. There's no x's and no y's here, so this looks a little bit weird. Okay, so this is called, the way that we say this is A sub n. That's how you would say that there. It's kind of like your y value. Okay, so our equations that normally have x's and y's, this is going to have an A sub n. It's different than y's and x's because it's about an arithmetic sequence instead of the other thing, the regular old equation. This guy, we say a sub 1. That's how you say it. That's why I put the little quotes there. A sub 1. And that is your first term. Okay? So that's the piece you have to find or know or be able to see with your eyeballs because it's not hard. N minus 1 stays there. And this D is your common difference. I'll tell you why we would like to find these. But let's make sure you have that written down first. Okay, so let's go to this one right here. Oh my gosh. Let's go to that one that we just did. So we're going to kind of work backwards up the page. I want you to write down A sub n. So the big A with the little n, please. Hello. Okay, thanks. That you are leaving. So I asked you to write down A sub n. Okay. Is it equal sign? This one's easy because I gave you the answers. What's the first term? 10. Okay, it's just gonna have an n minus 1. And what's the common difference? -2. So just put it like that with parentheses and you're done. Guys, it's kind of like point slope form. So you can see that a little bit. This is like a y value. This is like your slope. It's kind of like point slope form. Let's do this one. So work your way up the page. Again, I gave you the information you need. Oh, it's not y. A sub n equals, what's our first term? 2. Got to have an n minus 1. What's the common difference? 5, because it just says that, right? Boop, done. There's your equation. So 2 plus n minus 1 times 5. Now, flip back to, we're going to keep working our way up here. This guy, so should have this one written down. Both of these you should have written down. Let's find his equation. Okay, so this guy right here with the star next to him. Please write his equation based on what I just told you and the formula. It's not your choice. Okay, so A sub n equals, what comes first? 101. Okay, so that A with the little 1, one more time, the A with the little 1 is your first term. This time I didn't list it for you, but it's right there. You can find it because it's there. Okay, plus n minus 1, because it's got an n minus 1 in there. And then what's our common difference? -9. Okay, let's go back here. You guys, I need you to, here's the deal. We have to do this until I feel like you get it. So if you're not participating, you end up extending the pain for everyone. So if you're like, I get this, why does she keep doing examples? It's because the world is not paying attention and I need you to participate. Okay, so here's what I would like you to do. I would like you to write the equation or the formula. Sometimes they're called formulas. Write the equation and then find for me the next one term. Okay, so not the next three, but the next one. Okay, write the equation and the next one term. So this is your first number, which is, and then figure out what you're adding or subtracting by. Because it has to go up or down by the same amount every time.
So what I do, I minus 4.
So the n minus 1 will never change.
Okay.
It's always an n minus 1. Okay, so a sub n equals, what's the first thing we have? 4 plus, so this is a good question. McKinley asked, this is always an n minus 1. That will never change no matter what. Okay, so don't change that based on anything. And then what's our common difference? 11, because 11 is what we're adding by every time. Okay, what's the next number?
48.
48, because add 11. Okay, we're gonna do one more. Well, let's do this one. This one's pretty easy here. Okay, same thing. I'd like the equation and the next term, please. The equation and the next term. And then what does it do to change? Okay, so A7. Yep. And there's always a plus in the formula. And then there's always an n minus 1. And then what happens in your pattern? I know you know it because you already wrote it down. What happens? Yes. Okay. What's your equation? A sub n equals what? 95 plus. So here's, I had this question from a couple people. It's a good one. There's always a plus in the formula. That won't change. It's n minus 1. That doesn't change. What's the pattern? What about it? Minus 5 because it goes down. Okay, make sure you put it in parentheses. What's your next term? 75. You may put your things away. Nope, we'll have homework on Monday on that.